So in thesis writing, regression plays key role. Okay. Therefore, you must be very careful in today's class. And when your data does not follow the normal probability assumption, then you can use the non-parametric statistics. So now I am making Sneha as the host. Today Sneha ma'am will teach you. Okay, Sneha, now you can start.
Okay, sir. স্ক্রিন দেখা যাচ্ছে?
হ্যাঁ, দেখা যাচ্ছে।
Okay. So now we'll be dealing with regression. So for the understanding, regression goes one step further than correlation. I have already taught the part of correlation in previous classes. Hope you have seen the recording. So this goes one step further. What is the regression? Regression is a statistical method which is used to model and quantify the relationship between the dependent variable and one or more independent variables. Here the dependent variables are called the response. Okay. And the independent variables are called predictors. Sometimes we use the word also covariates. But here we will not use the word covariate, we will use the word predictor. It helps why this regression is needed for us, what the answer we get from. How much will y change if x changes by 1 unit? What is y here? Y is dependent variable, which is called response. I have already told it is the response, the dependent variable. And this is independent variable. Y is dependent on x. There can be many relationships, like there are linear relationships, there are polynomials, there are logistic regression. Those are separate parts. We will be covering with the linear, only with the linear regression, not the other parts. So the basic need of regression is to gain the prediction, the explanation, and the inference. The main point is it doesn't show us the association. Okay, it doesn't show us just the association. It gives us the prediction and the explanation. So what is the purpose? I have explained in one or two words. I will be covering with some examples also. Regression is used to predict the outcomes, like in survival analysis, to predict the survival time. Okay, there is an example of survival analysis to predict the survival time, the income, and the disease risk. These are some uses. Measure the effect of predictors on an outcome. Adjust for confounding variables. Confounding variables means variables which are actually hidden. We don't know the exact association. These are hidden causes of some response. Okay, we will be dealing with later. Test hypothesis about the relationships we know from regret. So, this part is clear. I hope this part is clear. Going to the next slide. So, we are dealing with only the linear regression. Though there is a general regression model that we denote as y equal to b naught plus, sorry, not b naught, that is beta naught plus beta 1 x1 plus beta 2 x2 up to beta p xp plus epsilon, where y is the this part. Y is the dependent variable, as I have already told. Beta naught is the intercept, where in linear regression beta naught is the beta naught is denoted by A. Okay, and the beta I we denote by beta I, that is the regression coefficient. But in linear regression, we only have this part B, not the beta I. Okay, and this is the independent variable, and this is our error term. Okay, the epsilon is our error term. So, what is the meaning of this part? This is sorry, huh, this is A. This part is intercept. When the value of y when x is 0, that is when the independent variable gives the value, takes the value 0. Okay, that means we are dealing with the base case. Okay, when we are dealing with the base case, we get the value of intercept, right? Then B is the slope, expected change in y for 1 unit change in x. Like if x, the value of x changes, then value of y is also getting changed, right? Beta B here we usually denote in stats beta by beta, but here I have denoted it as B. Okay, that's fine. It is the slope, the expected change. It is also called the regression coefficient. Okay, this epsilon is the error part. This is the unexplained variation. You cannot explain it. The model can't explain this part. Okay. So, what is the interpretation? When beta or B is greater than 0, Y increases as X increases. Okay. It is, you can see from the linear regression set that if the B is greater than 0, then as X increases, Y also increases. Right. When B is less than 0, then this part is negative. As x increases, y decreases. Right? I hope this part is clear. What the r square means in stata or r, we get this part r square. The percentage of variation in y explained by x. Okay? This we need when we do the inference or when we explain the result, then we need this part. The percentage of variation in y explained by x. P value I have already told is x a significant predictor. I have already told what is the significance of p value. Why we need it in linear regression? Is x a significant predictor of y? To judge this, so there is a point that high r squared doesn't imply the causation. It implies it only we get the better explanation, not the causation. We have to keep it in mind that R square never judge the causation, or we can't. There is another part like causal inference or another part we have for this causation like of things, but here we can't get this. Okay, moving to the next slide. There is a common misconception in students between the correlation and regression. So I have cleared it here, given this chart. You can look it, have a look. Like, what is the relationship? Like in correlation, what is our main focus? So
Ma'am,
giving
slides is not changed. Slides not changed. Not,
okay. Which slide is visible now?
12. Regression, deeper understanding. The first slide is showing.
Okay, okay. I have moved to the next slide. Is it visible now?
Yes, ma'am.
Which part you can see? The equation? Can you see
Now,
the equation?
yes. Now I am saying the
Okay,
regression model explained, like meaning
okay,
term and. Okay, ma'am. Okay,
okay,
ma'am.
okay.
Thank you.
So should I explain it again, or you can have
Ma'am,
the
please explain it again. Then it will be
okay, okay.
easier for me to understand.
Yeah, 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 sure. So here, y, I have already told it is a dependent variable. Okay, and this is the independent variable. And a, this part, what I have already said that beta naught. Here I have mentioned it as a. Okay, it is the intercept. This part. This is the intercept. What does it mean? When the value of x is 0, then we get only the part of intercept. Don't consider this error part now. Okay. We will be dealing with it after that. Only deal with this part. When we have the x value is 0, then we only have the part A, the intercept part. So we are dealing, when we are dealing with base case, right? The 0, x value is 0 means we are dealing with the base case. Okay. So we get the part of intercept. And this is beta, beta I actually. In a general regression, we denote it as beta I. Okay. In linear regression, we don't have beta i's. We only have the B part. That is only we denote it as beta 1. But here I have denoted it as B. That is the slope. What does it mean? Expected change in y for 1 unit change in x. Like you can see, if I put the value of x here, like x is 1, x is 2, then the value of y is also getting changed, right? So this is the expected change. You are getting it right?
Yes, ma'am.
Okay. So, and this part is the unexplained part, that is we are dealing with variation. This is out of our control. We don't have anything like the error part, unexplained variation. Okay. So how the model changes? What is the interpretation of regression result? It there is a vital role of b here. Okay, if b is greater than 0, what does it mean? If the x value is increases, then the y value is also getting increased, right? Because the whole part is positive and this part is also increased, then the y part is also increasing, right? If the b is negative, then this part gets negative. Then if the x value is getting increased, then the y value is also sorry, then the y value will be decreasing, right? Because this part is negative. Where is the curve? Oh, yeah. This part is negative. As the x value increases, then the y value will decrease. Okay. This part, when we are dealing with any software like R Stata or any other software, this part will give you the result, that is the percentage of variation in y explained by x. Okay, that is the variation percentage of variation in dependent variable by explained by the independent variable. I have already taught the concept of p value. Why p value is needed here? Is x a significant predictor? Like it might happen that we don't know the exact predictor, and we have to do some kind of hit and trial. Not exactly hit and trial. There are significant results. Like if the significance of this predictor is some cross the threshold, then we will be adding it or we will discard it. There are some concepts, but we are not going that much deep here. So to judge is the predictor is significant or not, we need the p-value. And the extra note is this: high R square doesn't mean the causation. It only explains the result better. For causation, we have different theories like causal inference. I have already told there are different theories, but through regression we don't get the idea of causation. Okay. Hope this slide is clear. Any question?
No, ma'am.
Okay. Moving to the last slide. So before going to the last slide, sorry, uh, I will be explaining the assumptions. So what are the assumptions when we should use the regression? The linearity assumption, as we are dealing with linear regression, so the linearity assumption is there, obviously. The independence, the variables, like the independent variables, should the covariance of, like, when we are dealing with general regression, then there can be the independent variables like x1, x2, x3, many variables are there. But here, this is the simple linear regression, so you can understand that is independent. And homoscedasticity, what is homoscedasticity? The variance will be homogeneous. Okay, the normality of error. This part is out of our reach, but what we can say that this part follows normality assumption. Okay, that this part is normal. Normal 0 sigma square, we usually note it like epsilon follows normal 0 sigma square. Okay, so there is some misconception among students for correlation and regression. So there is the difference between correlation and regression. So what is the focus in correlation? We just denote we just get the relationship. Okay. In regression, we have the prediction. Like if X changes, how much the Y gets changed. Okay. In correlation, we just have the relation if there is any relation in between X and Y, right? The variables for correlation, it is symmetric. Like if X is related to Y, then Y is related to X. Okay. Like if we say the covariance of xy equal to something, covariance of yx equal to same, it is symmetric. But in regression, it is not symmetric. Like you can't put x equal to a plus by plus epsilon here. You have to put dependent variable in this side, left side, and the independent variable right. Like y equal to a plus bx plus epsilon. You can't exchange the position of x and y. It is not symmetric. Okay. What you can do in correlation. In regression, it is not allowed. What is the output for correlation? The correlation coefficients are, I have already told in previous classes, I am not re-explaining it. And in regression, we have this equation. Okay. The significant change can be measured from this. We have this equation. So, in correlation, there is no direction. In regression, we have directions, like I have already told, the positive direction, the negative direction. There are some directional changes. So what is the flow? Like when should we do correlation? When should we do regression? I have already told in this difference table, but there is a flow chart. Like compare, relate, predict. In t-test, what did we do? Mean difference we have covered. That is the compare averages. In t-test, in the slide, you can see the core idea of t-test to whether two averages differ more than the expected by chance or not. Okay, so this is the flow doing work. If we have data, what we need first, we need to compare. Then we need to relate, measure the association, correlation. By correlation, we will measure the association. Then we will predict for future. We will predict by regression. Okay, this part is clear. Hope. Any question? Anything?
No, ma'am.
Okay. So parametric is done. So have you covered the previous concepts like the t-test and the correlation part? What I have taught earlier.
Um, that class I have last week, Friday and Saturday, due to my health issues, I could not attend the class, ma'am. But previously,
Oh,
whatever you taught us, I go through that, but not fully covered, ma'am.
okay. Okay. So please cover those parts. Okay, because the course will end by tomorrow. Like, yes, the course of this parametric, non-parametric will end by tomorrow. So cover those parts. Uh, okay.
Okay,
So
ma'am.
yes, is my slide visible? Non-parametric statistics part.
Yes, ma'am.
Oh,
Ma'am, no, this is the last slide, ma'am. Correlation versus regression conceptual. This slide is visible to me.
okay, okay. Wait a second. Now,
Mm. Now
Yes,
comes.
ma'am.
okay. So we have already covered the parametric statistics. I have already told that there are two major parts, parametric and non-parametric statistics. Parametric has already been covered. Now we will be dealing with non-parametric part. So what are the parts we will be covering? The concept, uses, example, procedures, and comparison, obviously. And I will be dealing with this part only for today. And this part will be covered by next day. So chi-square, Spearman rank correlation, and bandwidth. So uh, we were good with the parametric test. Then why do we need this non-parametric, like this complex concept? Why do we need? So there are some scenarios where we need these non-parametric situations. Like in parametric, we already told that the normality assumption is there, right? But when we are not dealing with the normality assumption and we don't know whether the data set is following normal distribution or not, then what to do? Just a second. I will be coming in 2 seconds. Just a second.
এটার মধ্যে কি আনবো?
চা পানি খাও।
যা পারিস না ডিমের আমি বলছি এর মধ্যে তো ডিমের ইয়ে আছে ডিমের ঝোল
ডিমের
ভাত
হ্যাঁ হ্যাঁ ভাত না শুধু রুটি দুটো রুটি
এর মধ্যে আনবো
এর মধ্যে
বলে বলে ফেলেন বলে
যা হবে হবে সরি so okay, so why do we need non-parametric test? So many real data sets are not normally distributed. Okay, and in previous lectures we are dealing with numbers and quantitative data, but here we have ordinal or nominal data, that is qualitative, and the sample size must be small here, presence of outliers, and the parametric assumptions fails. The parametric assumption mainly fails when the normal distribution is not followed. Okay. These are the situations when we need the non-parametric test. Okay. So there is a comparison in between parametric and non-parametric test. So as I have already told this part, this also you can have a look. Nothing to explain here. So the first test I am dealing with, that is chi-square test. Okay. Okay. In previous section, any question like why do we need non-parametric test? Is it clear?
Ma'am, please repeat once. Actually,
Oh,
I have to receive a
okay,
call at that call. That's why.
okay, no problem. So in non-parametric, what were the assumptions? Sorry, in parametric, what were the assumptions? Can you tell me the assumptions we have in parametric test, like t-test, and above we didn't cover, like in t-test.
Sorry, ma'am.
In parametric test, what are the assumptions we have? Like under some certain circumstances, we use the parametric test, right? We just we just have the data set and we can't blindly use any test. We have to have some assumptions right here. So okay, I'm re-explaining that. In parametric test, the assumptions were normality. Okay, that the data set is following normal distribution. We assume that the homogeneity of variance, that word I have said, homoscedasticity, the independence of the observations, that we are taking random samples, we already use the word IID, that is identical and independent observation. We use when we collect random samples, we use the word IID, and the data must be in ratio or interval scale, and no extreme outliers were there. So for these are the assumptions in parametric test we have. When these assumptions are getting violated, we use non-parametric. Okay. So the first assumption was normality for parametric test. For non-parametric test, what will be if many data sets are not normally distributed. Okay. First assumption got violated. After that, I am skipping the homoscedasticity part. It is a bit deeper concept. So just keep in mind the word homoscedasticity. Okay, nothing. After that, we were dealing with interval and ratio data in parametric case, right? But in non-parametric case, in parametric case, the data was quantitative, but here the data is qualitative, and we are dealing with ordinal and nominal case. Okay, ordinal and nominal data. Just a second. And the sample size is small here. The presence of outliers is also there. In parametric case, the outliers not be extreme. Right. I have already told for the assumptions. In parametric case, no extreme outliers must be there. But in non-parametric case, there can be outliers. Okay. In this process, the assumptions of parametric cases are getting failed. That's why we need non-parametric. Is it clear now?
Yes, ma'am. Thank you.
So just have a look in this page. What I have explained earlier, this part is there in just some key points. So we'll be starting with chi-square test. So no questions you have, right? So we can start this part. Like the assumptions are clear already. Okay. I hope.
Yes, ma'am.
Okay. So chi-square test, in if you say in layman language, it's kind of a reality check. Like we give reality check to our friends for some cases. So it's kind of a reality check. So in statistical language, we say that chi-square test is a statistical method used to determine if there is a significant difference between the observed data and the expected data. Like, suppose I have some expectation about my HS result. Okay, I had some expectation once about my HS result, but I have seen that the observed result is something else. So I have the reality check, right? So there is a difference between expectation and the reality. So why do we need chi-square test? When the data is categorical, that is nominal, not numerical. Okay, we will be dealing with the example. You can see. And we are dealing with frequencies or counts, not the means. In t-test, if you go through the previous PPT, you can see that in t-test we are dealing with mean differences. But here, there is no scope of means. We are dealing with frequency or counts. In parametric test, that is t-test and ANOVA. ANOVA we didn't cover, but t-test already covered. Cannot apply, cannot be applied. Parametric test cannot be applied here. Because the reason is simple, right? The assumption got failed and we don't have the scope of mean, then how can we use the parametric? So, what do you want to study here? Whether the observed data fits a theoretical distribution or not. This is the first case. And another case is whether two categorical variables are associated or independent. There are actually two types that is for chi-square test, that is goodness of fit test and test of independence. There is also a type that is the homogeneity test. I am not covering that part because in previous course I have only covered these two parts, fitting test and independence test. So I am covering this part only. I will be telling the homogeneity part, not in great details, but I will give an overview. Okay. So why do we need chi-square test? Is this part clear to you?
Yes, ma'am.
Okay. So for goodness of fit test, the test is used when you have one categorical variable from a single population. It determines if the sample data fits a distribution you expect. Like, uh, hello, uh, are you telling something or should I continue?
Yes, ma'am.
Okay. So when to use it? To see your observed count match a specific ratio or theoretical distribution. Like there is an example. A die is thrown 120 times. Is it a fair die? Like the expected frequency for each phase is 20. Compare the observed and the expected frequency. Like we have thrown the die 120 times. Then we have some observed frequency we have, and the expected is mentioned here. Expected frequency is mentioned. If the difference is significant, then we will be saying if this is our assumption, it is good to fit or not. Okay, this is the goodness of fit test. What we test here to see the observed count matches a specific ratio or theoretical distribution or not. Like we don't have the assumption of that distribution, we are just expecting that okay, this data is like this kind of thing. So it can fit with this theoretical distribution. And we're testing our assumption. Okay. And this is second part that is test of independence. So it is the most common version. It is used when two categorical variables from a single population. It determines if there is a significant association between them or not. So, like there is an example of gender and force preference. Like it might possible that male population prefers science maximum and female gender uh, are tend to going for arts. It might happen. It might not be also. So we are testing whether there is any relation or they are independent or not, like gender and the course preference. Is this two independent or not? Like you can see gender and course preference both are qualitative, not quantitative, right? Gender and course preference. You are getting it, right? These are not quantitative variables. These are qualitative. Is this part clear to you?
Yes, ma'am.
So what are the assumptions? The observations are independent, like for the male case and the female case, these are independent, right? There is no association between the male and female. There can be any association between gender and force preference. We will be testing it with the independence test of chi-square, but the observation must be independent. The data must be frequency data. You can see here the frequencies, this part. Expected frequency preferably greater than equal to 5. Categories must be mutually exclusive, like no overlapping. A person cannot be in male and female at the same time for this case. It, there must be another category for non-binary or something like that. A person cannot be considered as male or female simultaneously. Non-overlapping, mutually exclusive must be there. So, what is the hypothesis we need for both of each of the cases? For goodness of fit, what is our null hypothesis? The observed frequencies follow a specified distribution. Like as you can see, if I say the die is fair or not, like I am thinking that okay, this can be a binary list. I am thinking about. I am not sure whether it is or not. A specified distribution is followed. What is the alternative? It is obviously the opposite of the null hypothesis. For independence test, what is the null hypothesis? That is two attributes are independent. The gender and force preference, they are independent. This is our null hypothesis. And for alternative hypothesis, it is associated. We are so the test statistic. This is the is this visible? The test statistic part is
Yes,
the
ma'am.
formula visible? Okay. This is observed. This is expected. For each of the cases, we have the observed frequencies, the and the expected frequencies. We are taking the difference. We can deal with the magnitude, the positive magnitude. We don't need the negative part. So we are dealing with the squares. Okay. Not the modulus, the squares. And summing them up, dividing by the expected frequency. This is the test statistic. Okay. Test procedure part visible to you?
No, ma'am.
This slide?
So many slides. Now, ma'am, it shows.
Okay, okay. This is the test procedure that I have already stated the null and the alternative hypothesis. Construct the contingency table. This is the contingency table. Okay. Usually, in most of the cases, like for base cases, we deal with 2 into 2 contingency table. Though this is not 2 into 2, this is 2 into 3 contingency table here. In for basic examples, initially we give that smoking habit. Like if in gender and the smoking habit are they for independent or not? For this, it's a bit not, I would say it's not complex, but a bit higher. So compute the expected frequencies that E part. We have the observed frequency, but what about the expected frequency? We need that, right? So what is the calculation for that? Just a second. Sorry, actually, I'm questioning. Is my PPT visible to you?
Yes, ma'am.
Somehow present. So, স্ক্রিনটা দেখা যাচ্ছে তো এটা বড় করা যাচ্ছে না। আচ্ছা, so what is the expected frequency? The formula for expected frequency is row total, column total by the grand total. For this part, this is the row, calculate row total, column total obviously, and the grand total will be this side, right? That is the expected frequency. Calculate the chi-square using the formula. What I have already told the formula. This portion observed is there. Expected frequency I have already told by this formula we'll get the expected frequency, and from this formula you will be getting the chi-square. So the degrees of freedom, goodness of fit, the degrees of freedom is k minus 1, and for the independence, that is r minus 1 minus into c minus. What is r here? R is the number of rows and c is the number of columns. Okay, it will be r minus 1 into c minus 1. What is the decision rule? This slide is visible, right? And the text are also visible. Actually আমি এটা বড় করতে পারছি না, প্রবলেমটা সেই জন্য হচ্ছে। দেখতে অসুবিধা হচ্ছে নাকি বোঝা যাচ্ছে?
আমি তো দেখতে পাচ্ছি।
আচ্ছা,
হ্যাঁ ম্যাম, দেখা যাচ্ছে।
হ্যাঁ একটু ছোট হয়ে আছে।
ওটাকে প্রেস করলে একটু বড় হবে।
হ্যাঁ এটা অ্যাকচুয়ালি হচ্ছে না, আমি প্রেজেন্ট করার চেষ্টা করছি। Error starting online presentation. Okay. Hope the procedure is clear, right?
ম্যাম, আমরা এটাকে বড় করতে পারছি, আমি বড় করে নিয়েছি।
Okay, okay. Then it's fine. The procedure is clear, right? How to calculate the chi-square part is clear, right?
ইয়েস
Any
ম্যাম।
question? Okay. The calculated chi-square, now we have the calculated chi-square. We have the power. Okay. We have the power in our hand. So, to like use the power, obviously. So chi-square from table. So how will we get the part? We have to use the table, okay? And the chi-square, we have the degrees of freedom. For goodness of it, we have chi-square k minus 1. You will get the value of chi-square k minus 1 from a statistical table. And for independent test, the degrees of freedom will be chi-square r minus 1 into c minus 1. You will also get the value from the statistical table. Okay. What is the decision rule? Decision rule is if the calculated chi-square is greater than the calculated chi-square is greater than the tabulated value, then we will reject the null hypothesis. If the calculated chi-square is less than equal to the tabulated value, then we will fail to reject the null hypothesis. So till here we have the hypothesis, we have the test statistic, we have the expected frequency, the observed frequency, we have the degrees of freedom, we also have the statistical table. So the decision rule is also there. So up to this part, any question, or if I give you one uh, mathematical problem, will we able to be solve it?
Yes, ma'am.
Okay. So in assignment, I will be giving a problem. Okay, regarding this.
Yes, ma'am. No issue. But how I write, one thing is there. I can do it on copy, but how in computer? I don't have idea how to do there because we
Actually,
have to
the
submit
assignment
there.
will be
I
assignment
don't
will
have,
be an MCQ actually.
but I know how to do the chi-square. I attend my
Okay,
coursework also. I got full marks.
okay. So, like, what is your question? I am confused actually.
Actually, I know how to do chi-square math.
Okay,
In copy, I can do it manually, but I don't know how to do there in Excel sheet or Word. We are writing in Word now. The assignment, how to do there, I don't know.
like in what you have to type actually.
Yes, I have to type, but this so many portions are there now. Expected frequency is equal to আমাকে লাইন টানতে হবে ওপরে ফর্মুলা নিচে ফর্মুলা বা এইগুলো কি করে লিখবো এই জায়গাগুলোতে আমার ডিফিকাল্টিস আমি কোনোদিন করিনি কিন্তু কপিতে দিলে আমি করে দিতে পারবো এটাই বলতে চাইছি
Okay, you can
তাই
have the option like do it in copy, then click the picture and paste it in Word. That is the only way I can say.
ওকে ম্যাম আই উইল ট্রাই আই ডোন্ট নো
কাজটা লিখতে
বাট
গেলে
আই উইল ট্রাই
এই স্নেহা,
হ্যাঁ হ্যাঁ
স্নেহা আমাকে একটু বলতে দাও। যখন যে প্রশ্নটা করছে জলি, যখন তোমরা কাই স্কোয়ারটা লিখবে, তখন কাই স্কোয়ারটা লিখবে তো সিম্বলটা দিলে, তারপরে ব্র্যাকেটে থাকবে ডিএফ ভ্যালুটা। ওকে, ডিএফটা দেবে। ডিএফ ভ্যালু যদি তোমার 2 হয় তুমি 2 দাও, ডিএফ ভ্যালু যদি 4 হয় তো 4 দাও, ভাবে যাবে। তারপরে ডিএফটা তুমি উইদিন ব্র্যাকেটে থাকবে, ইকুয়াল টু কাই স্কোয়ার স্ট্যাটিস্টিক্স যেটা দিচ্ছে সেই ভ্যালুটা লিখবে, দিয়ে কমা, নিশ্চয়ই সেটা সিগনিফিকেন্ট যদি হয় তবে সেটা পি লেস দেন ওই 0.05 বা 0.01 এইভাবে তোমাকে লিখতে হবে। ওকে, এবার ইন্টারপ্রিটেশনটা যখন তুমি করবে তখন তোমাকে দেখতে হবে যদি ওটা সিগনিফিকেন্ট ডিফার করে, দেখতে হবে ফ্রিকোয়েন্সিটা কোথায় বেশি হয়েছে। ওকে, যে জায়গায় ফ্রিকোয়েন্সিটা তোমার সবচেয়ে বেশি হচ্ছে তার উপর বেস করে তুমি ডেটাটাকে, ফ্রিকোয়েন্সি বেশি হচ্ছে মানে তোমার যে কলাম পার্সেন্টেজটা বেরোবে, সেই কলাম পার্সেন্টেজটা একটা বেরোবে। ধরো তোমার তিনটে গ্রুপ আছে, তো 1 2 3 তিনটে ধরো গ্রুপ আছে। তো এবার যদি দেখা যায় যে কলাম পার্সেন্টেজের 2টা সবচেয়ে বেশি হয়েছে, তার মানে তুমি বলতে পারবে যে তোমার 2 ক্যাটেগরি যেটা, সেইটা ওই পার্টিকুলার যে ভেরিয়েবলটা তুমি মেজার করছো সেক্ষেত্রে তারা বেশি পারফরমেন্স দিয়েছে। এইভাবে তোমাকে জিনিসটা বলতে হবে। ওকে, তারপরে তুমি যদি তোমার কোনো লিটারেচার থাকে তখন তুমি তার সাথে জিনিসটাকে লিটারেট করে লিঙ্ক করে দেবে। এবার জিনিসটা
ওকে
বোঝা
স্যার,
গেল?
আমি ওইটা, হ্যাঁ আপনি যেটা বলেছেন বুঝেছি। আমি বলছিলাম যে আমরা প্রথমে একটা ওই টেবিল মতন করে অঙ্কটা করি তো,
হ্যাঁ, একটা টেবিল
মানে
তোমাকে
ম্যাম
দিতে
যেটা
হবে।
অঙ্কটা
এই
একটা
টেবিলটার
দেখাচ্ছিলেন
মধ্যে
একটা টেবিল করে, হ্যাঁ
টেবিলটার
ওই
মধ্যে তোমার
ওইটা কি করে
থাকবে
লিখবো কি
ফ্রিকোয়েন্সি।
ওইটাই? হ্যাঁ
হ্যাঁ,
হ্যাঁ, ফ্রিকোয়েন্সি গুলো
টেবিলটার
থাকবে,
মধ্যে
টোটাল
থাকবে
থাকবে আবার।
ফ্রিকোয়েন্সি। হ্যাঁ,
হুম,
ওকে,
ওইটাই
ফ্রিকোয়েন্সিটা
বলছিলাম যে
থাকবে।
ওইটা কি করে করবো
আর
ফর্মুলা।
তোমাকে, হ্যাঁ, কতর মধ্যে কত মানে থাকছে, তো ফ্রিকোয়েন্সির পরে তুমি পার্সেন্টেজটাও দিতে পারো যদি তুমি মনে করো। পার্সেন্টেজটা দাও, তারপরের কলামে চলে যাবে কাই স্কোয়ার স্ট্যাটিস্টিক্স, তারপরের কলামে হবে ডিএফ, আর তারপরের কলামে হচ্ছে লেভেল অফ সিগনিফিকেন্স, পি লেভেলটা। ওকে, এইভাবে তোমাকে টেবিলটা সাজাতে হবে।
ঠিক আছে স্যার, আমি ট্রাই করবো, যদি অসুবিধা হয় আপনাকে বলবো তাহলে।
ওকে, শিওর। ওকে, স্নেহা, কন্টিনিউ।
Okay, sir. So I will be discussing one more part, that is homogeneity test. Just an overview I will give. What is the study design for homogeneity test? You take multiple random samples from multiple population or groups. So what are the variable counts here? You measure one categorical variable and compare its distribution across those groups. Like, what can be the question for the homogeneity test? In the distribution of this variable, the same for all these groups. Like we have a group for male and a group for female. Okay. If the movie genre, it can happen that horror movies are more preferable for men. For women, it can be romantic movies. Like, so which type of movie is preferable for this sample, for men and for women? One example I would, numerical example I would say, like you can take a sample of 200 male and separate sample of 200 female. So you ask both them a question, which type of movie do you prefer? And what is our need? We want to see if the distribution of movie tastes is the same for both of the genders. It might happen that taste of independence and the taste of homogeneity looks similar, but there are some significant differences which you have to keep in mind. For independence test, we are dealing with one sample only. But in homogeneity test, we have two or more samples. In independence test, we deal with one target population, that is single target population. But in homogeneity, we have multiple target population. So what is fixed here? In independence test, only the total sample size, that is the small n, is fixed. But in homogeneity test, for the sample size of each group is fixed here. Like I have mentioned 200 men and 200 women. Okay. The sample for each group is fixed here. So what is the null hypothesis? For independence test, I have told the null hypothesis can be, suppose variable A is independent of variable B or not. Okay, this is the hypothesis. This I want to test if the variable A is independent of variable B or not. For homogeneity, the distribution of variable is same across the groups or not. Okay, is this homogeneity part clear? I'm not giving the full explanation of homogeneity, just giving an overview and a bit comparison in independence and homogeneity. Is it clear?
Yes ma'am.
So, the difference between chi-square and parametric, this is non-parametric equivalent that I have already told you. These slides are meant for non-parametric. This is used only for frequency data, doesn't compare mean. This part I have told, so I'm not re-explaining this part. So the I hope the chi-square part is totally clear to you, and if I give you some numericals, you will be able to do this. So moving to
Yes,
the
ma'am.
next. Okay. So this is Spearman rank correlation. Okay. So Spearman rank correlation is a non-parametric test used to measure the strength and the direction of the association between two variables. Unlike the most common Pearson correlation in parametric, we are dealing with Pearson correlation. Here we are dealing with Spearman rank correlation. So in parametric, unlike the most common Pearson correlation, we look for a straight line relations, right? But Spearman looks the monotonic relationship. That means as one variable goes up, the other tends to goes up or down. It is not necessarily to be constant. Okay, the monotonicity of the relationship we make. So why do we use it? Data are ordinal or ranked rather than numerical. The relationship between variables is monotonic but not linear. I have already told the monotonic relationship is non-linear, right? The data do not specify normality assumption. The whole non-parametric case is dealing with non-normality assumptions. There are outliers that distort Pearson correlation. In Pearson correlation, we can't deal with outliers, but here we can deal with. So Pearson correlation is a linear association using raw data, but Spearman measures the monotonic association using ranks. So this is the situation when we have to use this Spearman rank correlation. Data given in rank, then Pearson correlation cannot be used. No normal distribution outliers present. This part I have explained. This is the okay. So just have a look. No need to re-explain. The situations and the background is clear, right?
Yes, ma'am.
So there can be two types of cases, tight case and non-tight case. So I am explaining two cases, just giving you some overviews. Okay. For without tie case, this is the most simple case when every data point in our dataset has unique rank. No two items are equal. How it works? I assign a unique rank to each value and calculate the difference. We will be dealing with the statistic. Then you will see that the difference, what the difference is between two ranks of variables. Like example can be two judges rank 10 different paintings from 1 to 10. No two paintings can share the same rank. We use Spearman correlation to see how much the judges is. For the second case, it can be tied case that this is used when two or more observations have the same value. How it works? You assign the average rank to the tied values. For example, if two items are tied third and fourth place, you give them both 3.5 rank. Like you cannot give one to third and another to fourth. They are scored equally. So what we will do? We will give 3.5 rank to each of them. The formula adjusts slightly for account of type. So what is the example? An example can be suppose you are comparing hours of study and test scores. Okay, two students both studied for 5 hours. You assign them the average of rank they would have acquired. Is it clear for the tight case how we assign the rank? Like we are taking For 2, like for 3 and 4, 3 plus 4 by 2, that is 3.5, we are assigning that. Like if we have three third places, then we will be dealing with 3 plus 3 plus 3 by 3. Right? Is it clear?
Yes, ma'am.
So there is an example like academic performance. A teacher wants to examine whether rank in math is related to rank in statistics among the students. Okay, then we have the numbers for math, we have the numbers for statistics. We will rank them. For math, we will be, suppose we have 10 students, we are dealing with first to 10, and for stats, we have the same, we are dealing with same. It can be tied or it can be non-tied case. The data ranks as Spearman correlation is appropriate here. And for the example, next, that the consumer preference, the customer rank brands based on quality and price statistics. Is there any association between two rankings? We'll be looking at this. What are the assumptions? The observations can be independent, like the judge's decision cannot be influenced by each other. Those must be independent. The variables at least ordinal, and the relationship is monotone. So hope the assumptions are clear and the examples also. Next, I will be showing the formula. That is my part. हाँ,
হ্যালো স্নেহা।
hello.
হ্যাঁ, তুমি কাই স্কয়ার পড়াতে গিয়ে ওই
हाँ,
একটা আছে না কারেকশন, সেটা একটু বলে দিলে ভালো করতে।
correction means মানে যখন
বলে না
অবজারভেশন গুলো।
এক্সপেক্টেড ফ্রিকোয়েন্সি, হ্যাঁ এক্সপেক্টেড ফ্রিকোয়েন্সি যদি 5-এর বিলো হয়
হ্যাঁ,
তবে সেখানে একটা ইয়েটস কারেকশন আছে।
আচ্ছা ইয়েস কারেকশনটা, হ্যাঁ আচ্ছা তাহলে আমি বলে দিচ্ছি।
হ্যাঁ,
অ্যাকচুয়ালি আমি
ওইটা একটু
অ্যাজিউম
বলে দিলে
করে
ভালো করতে।
নিয়েছিলাম যে অলরেডি ওটা গ্রেটার দ্যান 5, তাই আমি ইয়েস কারেকশনটা বলিনি। ঠিক আছে, আমি
হ্যাঁ
বলে
হ্যাঁ,
দিচ্ছি
বুঝতে
তাহলে।
পেরেছি। তোমার
হুম,
ডেটার মধ্যে ওটা ছিল না, কিন্তু আমার
হ্যাঁ,
পরে মনে পড়লো যে একটা কারেকশনের ব্যাপার আছে, সেটা বললে ভালো করতো।
আচ্ছা। তো ইয়েস কারেকশনের পোর্শনটা আমি একটু আলোচনা করে দিচ্ছি। Its correction for continuity is a mathematical adjustment applied to 2 into 2 contingency table. Okay. When we are dealing with 2 into 2 chi-square test, that is here we actually আমি স্লাইডটা শো করতে পারছি না, মেবি এটা আবার হ্যাং করছে। So in example you can remember that the table was not 2 into 2, right? It was 2 into 3. But for its correction it is for applied for 2 into 2. It was designed to make the test more accurate when dealing with small data sets. When we use a chi-square test, we are using a continuous probability distribution to estimate the discrete data, that is counts, right? This can lead an overestimation of statistical significance, especially when we have small number of samples. Yes, corrections shrink the difference between observed and the expected values to provide a more conservative result. So when to use it? When we have 2 into 2 contingency table, it is only used for two variables. When we have male, female, pass, fail, this kind of thing. Don't look at the previous example because it was not 2 into 2 contingency table. Okay, I am just telling the example using just theory, not practically. We have small sample size, as I have already told that the frequency is less than 5. Usually we consider 10 or 5. I am considering here the 5. Okay. The prevention of type 1 error. It is used when you want to be more cautious and avoid claiming a significant result when there is not one. Okay, we are dealing with, we are avoiding the possibility of type 1 error. So what is the formula? Just please note down the formula. The O denotes the observed frequency and the E denotes the expected frequency, right? So for the chi-square EX correction, it will be modulus of O minus E minus 0.5. In the previous formula, what we had, O minus E whole square. But here, we don't have the O minus E whole square. Instead, we have modulus O minus E minus 0.5 whole square of whole of this part. Are you getting my point? Should I write here?
Then please write it in chat.
Wait. Where is the white? লিখলে দেখা যাচ্ছে?
No, ma'am. Just slide shows here.
Wait, wait. 5 টা ফর্মুলাটা আমি দেখাবো কি করে, হোয়াইট বোর্ডটা তো খুলছি না। হ্যালো স্যার, আপনার কথাটা কেটে যাচ্ছে, আমি শুনতে পাচ্ছি।
ঠিক আছে।
হ্যালো
হ্যাঁ, স্নেহা, আমাদের যেটা শেখানো হয়েছিল সেটা হচ্ছে এফও মাইনাস এফই, তারপর তো তুমি করছো, ওটা আমাদের এফও মাইনাস 0.5
হ্যাঁ,
করিয়েছিল।
আচ্ছা।
তুমি বলছো এফও মাইনাস এফই
অ্যাকচুয়ালি দুটো
মাইনাস জিরো
ফর্মেটই ইউজ
পয়েন্ট ফাইভ
করা স্যার।
হ্যাঁ,
হ্যাঁ,
আগেই আর কি
আমি
0.5টাকে।
এখানে
হুম,
আমি ফর্মুলাটাকে হোয়াটসঅ্যাপে পাঠিয়ে দেবো গ্রুপে, কারণ এটা এখন খুলছে না, বেকার টাইম হচ্ছে।
হ্যাঁ, পাঠিয়ে দাও।
আমি হোয়াটসঅ্যাপে আমার ক্লাসটা শেষ হয়ে গেলে না হোয়াটসঅ্যাপে নোটটা পাঠিয়ে দিচ্ছি, সেটা বেটার
হুম
হবে, কারণ এখানে বেকার
হুম,
টাইম হচ্ছে, সেটা খুলছেই না।
ঠিক আছে।
হ্যালো।
Yes, ma'am.
O minus E minus 0.5 divided by expected frequency, na? OE.
হ্যালো, অ্যাকচুয়ালি কথাগুলো এত কেটে কেন
হ্যালো,
যাচ্ছে? হ্যালো। হ্যাঁ স্যার, কিছু
হ্যালো, শুনতে
বলছিলেন?
পাচ্ছি তোমার কথা। হ্যাঁ, আমি
হ্যাঁ
বলছিলাম
স্যার।
ও মাইনাস ই
হ্যাঁ
মাইনাস 0.5 ডিভাইডেড বাই ই।
হ্যাঁ, আমি যে ফর্মুলাটা বলছিলাম সেটা হচ্ছে ও মাইনাস এর আমি মডিউলাস ভ্যালুটা নিচ্ছি, মানে আমি পজিটিভ পার্টটা খালি নেব, -0.5, সেটার
হুম
হোল স্কয়ার থাকবে বাই ই।
হুম হুম, হ্যাঁ, বাই ই, হ্যাঁ। তারপরে তার সবগুলো সাম করলে সেটা কাই স্কোয়ার ইএক্স টা বেরিয়ে
হ্যাঁ
যাবে।
হ্যাঁ, কাই স্কয়ার। হ্যাঁ, মানে আমি এই ফর্মুলাটা বলছিলাম। আমি এটা নোটটা, মানে ফর্মুলাটা লিখে আর একটা কন্টিনজেন্সি টেবিল দিয়ে
এখানে
সেটা।
স্পিয়ারম্যান দেখাচ্ছে।
হ্যাঁ হ্যাঁ, কারণ ওই হোয়াইট
স্নেহা,
বোর্ডটা
এখানে
আমার খুললো না।
স্পিয়ারম্যানটাই দেখাচ্ছে।
হ্যাঁ স্যার, হোয়াইট বোর্ডটা খুললো না, তো সেই জন্য আমাকে এটা মুখে বলতে হচ্ছে, নাহলে
আচ্ছা,
আমি
ঠিক
লিখে
আছে, আমি
দেখাতে
ওটা
পারছি।
ওটা তো ঠিক আছে, বলে দেওয়া
আমি,
যাবে।
হ্যাঁ, এই ইয়েটস কারেকশনটার নোটটা, লাইক ফর্মুলা আর একটা টেবিল সমেত এক্সাম্পল আমি হোয়াটসঅ্যাপে পাঠিয়ে দেবো তো। ইট উইল বি
হুম
হেল্পফুল,
হুম
লাইক। ওকে, তো আমি স্পিয়ারম্যানটাই কন্টিনিউ করছি এখন।
হুম। এখানে একটা টাইড র্যাঙ্কের গল্প আছে
হ্যাঁ
স্পিয়ারম্যানের
টাইটেল,
ক্ষেত্রে, সেটা বলে দিয়েছো মনে হয়।
হ্যাঁ আমি বলে দিয়েছি, হোপফুলি স্টুডেন্ট বুঝতে পেরেছে।
এটা কি করে হ্যান্ডেল করবে?
হুম, কিভাবে র্যাঙ্ক হলে সেটাকে আহ মিনটা বের করে সবার মধ্যে ডিস্ট্রিবিউট করতে। So now, what is the hypothesis for this Spearman rank correlation? The hypothesis is there is no correlation between, আচ্ছা প্রিভিয়াস এক্সাম্পল গুলো বোঝা গেছে নিশ্চয়ই, যেটা ডিসকাস করছিলাম আগের স্লাইডে। এক্সাম্পল অ্যাজাম্পশন, এখানে কোনো কোয়েশ্চেন আছে?
No, ma'am.
So this part. So what is the hypothesis? There is no correlation between two ranks. That is, this row is zero. And what is the alternative? There is a significant correlation between two rankings. That is, the row is not equal to zero. It is both till test. The both till test is already covered in parametric test. So you have to look to that picture also. So what is the test statistic here? This is test statistic. The D is the difference between paired ranks. In example, I have already told. Uh, yes, somewhere I have told about the difference. So for each of the ranks, you can get the difference between the ranks. Suppose for student A, the rank of for the mathematics marks is 1. For statistics marks, it is rank 5. Then the D will be the difference between that paired rank. Okay, small n in is the number of observations. And from this, we have all the data. You can compute this row, right? So what are the steps? First, assign the ranks for both of the variables. For the mathematics marks and the statistics marks, you have to assign the rank for each of the students. We will compute the difference for the rank, that is the rank 1 and the rank 2. I am considering for the mathematics case, it is the rank 1 for that student and the rank 2 for the statistics case. The square of the differences, as you can see, because we are intended to deal with the positive part. We can deal with the modulus, but square is more easy to be handled, right? So we are dealing with the squares. And as usual, use the formula, substitute it and obtain the row value. Okay. So what is the decision? Compare the calculate row with the critical value or the p-value approach. The p-value approach is already being taught in the parametric class. So have a look. So what is the rule? If the p-value is less than alpha, then we will reject the null hypothesis. The procedure, the decision rule is always same. For parametric, for non-parametric, the decision rule is always same. Okay. When we are dealing with the p-value, if the p-value is less than alpha, reject null hypothesis. If it is greater than equal to, fail to reject the null. Hope this part is clear. So we had the Pearson rank correlation. Pearson correlation. Then why we are using the Spearman rank correlation? So this is the case when we need this. In Pearson correlation, we have interval data and normality assumption. That is parametric case I have already told. In Spearman, we have only the rank data. We don't have the interval data, we have the rank data and it is not normal. The Spearman less sensitive to the outliers. Like we can't deal with outliers for Pearson. We have to deal with outliers in Spearman. Is this part clear or any kind of question you have? The tied, non-tied case clear or not? The concept of tie and non-tie case? The difference between Spearman and Pearson? What to use, which one?
No question, ma'am.
Okay.
হুম,
So man Whitney কি আজকে শুরু করবো?
এটা নেক্সট দিন করিও। হুম,
উম, হ্যাঁ, কারণ অনেকটা আছে, এটা অনেকটা বোঝাতে হবে।
এটা অনেকটা বলতে হবে।
অনেকটা
তোমাকে
বলতে হবে।
প্যারামেট্রিক টি টেস্ট থেকে তারপরে নন প্যারামেট্রিকে ঢুকতে হবে।
হ্যাঁ, প্যারামেট্রিক টিটাসটা আগের দিন বলেছি, সেটার সাথে একটা কম্পারিজন আমি দিয়েছি স্লাইডে,
হ্যাঁ।
বাট এটা বোঝাতে হবে অনেক, টাইম নেই গেছে। তো ঠিক আছে, দেন এই টেস্ট গুলো ম্যান উইটনি সাইন র্যাঙ্ক টেস্ট, উইল কক্সন র্যাঙ্ক টেস্ট অ্যান্ড পুষ্কল ওয়ালে, সেগুলো আমি কালকে ডিসকাস করবো। কালকে ডিসকাস করলে আই থিঙ্ক নন প্যারামেট্রিকটা হয়ে যাবে।
বাহ, ভেরি গুড। ওকে, অস্মিতা তুমি কিছু বলবে? হ্যালো অস্মিতা।
হ্যালো হ্যালো।
হ্যাঁ বলো, তুমি কিছু বলবে
হ্যাঁ স্যার,
স্টুডেন্টদের?
না স্যার কিছু সাচ বলার নেই, বাট মার্কসটা কি করবো স্যার?
ওই যে মার্কসটা তুমি যে দেখাবে সেটা বলেছিলে না?
হ্যাঁ হ্যাঁ হ্যাঁ, দেখাবো এখন।
হ্যাঁ, দেখিয়ে দাও।
স্যার এটা
আচ্ছা
কালকে দেখালে ভালো হয়, কারণ শ্যামশ্রী তো নেই।
হ্যাঁ স্যার, মানে আমিও ভাবছিলাম, কারণ কি জাস্ট দুজনই আছে এখানে, জলি ম্যাম আর রিমা ম্যাম, তাছাড়া আর কেউ নেই। আর প্লাস মানে একটু ডিসকাশনও তো করতে লাগবে।
হুম, কেউ যদি তোমার ডেটে না আসে তখন তুই কি করবে?
সেটাই স্যার, না হলে একটা কাজ
আজকে
করা
তাও
যেতেই
ওরা
পারে
দুজন
এখন।
এসেছিল।
আমি দেখিয়ে দিলাম, বাকিরা পরে ইউটিউব থেকে দেখে নিল, বাট এটাই স্যার,
হুম,
পরে আবার
কত
কোয়েশ্চেন
তুমি আর
করবে।
করবে? হ্যাঁ,
স্যার শ্যামশ্রী তো জয়েন করে, কিন্তু আজকে প্রবলেম আছে বলে করতে পারেনি। কালকে
ঠিক আছে,
করলে
তাহলে
ভালো
কালকে
হয়, তাহলে ও
দেখিও,
থাকবে।
কারণ আমাদের এটাকেও তো টানতে হচ্ছে, স্টাডি
হুম হুম
আওয়ারটাকেও
হুম।
টানতে হচ্ছে তার সাথে।
স্যার, আমি তাহলে একটা কাজ করি, আমি গ্রুপের মধ্যে জানিয়ে দিচ্ছি যে কালকে রেজাল্ট ডিসকাস হবে, যারা আসবে আসবে, না
হুম,
আসবে তারা ইউটিউব থেকে দেখে নেবে।
হ্যাঁ, তাই
আই
করবে।
থিঙ্ক ঠিক আছে স্যার, তাই করি তাহলে। ঠিক আছে।
ঠিক আছে, ওকে। ওকে, থ্যাংক ইউ
ওকে,
জলি, রিমা, স্নেহা, অস্মিতা, থ্যাংক ইউ।
থ্যাংক
So
ইউ
থ্যাংক ইউ
স্যার,
স্যার।
থ্যাংক ইউ
now we
ম্যাম।
can close the session.
থ্যাংক ইউ ম্যাম।
Hmm.
গুড নাইট স্যার, গুড নাইট ম্যাম।
Good night.
গুড নাইট
গুড নাইট স্যার,
স্যার।
গুড নাইট এভরিওয়ান।
নেহা, তুমি আমাকে হোস্ট করে দাও।
আচ্ছা স্যার।